So, hello everyone. I think everyone is doing good. Everyone is okay. I hope so. So, today we are with immunity. Today we'll learn how this immunity is provided to us. Like, have you ever guys wondered like who actually provide us this immunity? Are these cells or liquids? Sorry. Yeah, I had a cat. Okay, she's disturbing me so much. Wait. Okay, so where were we? So who provided us this immunity? Okay, are these cells or are these liquids or what are those? So to know that, we need to understand the concept of humoral and cellular components. Okay, this humoral and cellular components, from them who is responsible, we have to know about that. So in earlier class we discussed about Pasteur's work about vaccination and all. So our Pasteur, he just showed us how vaccination work, but didn't know like vaccination work. He showed us, but didn't know how. So many believed it was the cells or it was the soluble agents. So in 1890, okay, in 1890, two researchers or scientists, you can say, Emil von Behring and Kita Sato. Okay, it's hard to remember this name. Okay, I'm really sorry, Kita Sato. So they got Nobel Prize also for their this discovery. So what they observed was, they gave us the first insight. Okay, known as the serum. The serum. Okay, so what they did was, this serum, it was the liquid extracted from the coagulated bloods. Okay, coagulated blood of animals immunized with diphtheria. Okay, diphtheria. Sorry for the background. Oh my god, the streets here are so busy, I can't even record a video nicely. Okay, so where were we? Okay, so the serum. So from serum, actually it was recovered from coagulated blood of animals who were suffering from diphtheria. Okay, so what they observed was, this serum, it could transfer immune state. Okay, immune state to those who were unimmunized. So this immune state they could provide to unimmunized animals. Okay, so before this, Eli Mechnikov, it's hard. Okay, Mechnikov. So we'll just write. So in here, 1883, Eli. Okay, so what he observed was, he also seen that some white blood cells. Okay, which he named as phagocytes. Okay, so these were more active when an invasion from foreign particles, like these phagocytes, they were more active in animals that has been immunized. Okay, so from their debate, it raised and all, then who is really responsible? Are these phagocytes, white blood cells, or the serum? So the debate, it went on. Wait, let me get a new word. Okay, so the debate, it kept going for decades. So the researchers, they did their work in around 1900s. Okay, sorry, my handwriting is so bad actually. Around 1900s. So they were mostly researchers. They were able to characterize the active immune components in blood. Okay, so what they did was, they actually, according to the activity they exhibited, like neutralize, precipitation, precipitate, and then agglutinate. So they gave them the name according to the work they exhibited, according to the activity they exhibited. So for, like, they named it as antitoxin, then precipitin, then agglutinin, sorry, I'm really sorry, agglutinin. Okay, so they thought they were responsible. Then again, they said that it's a fraction of this, what do you say? A fraction of serum, okay. A fraction of serum. This all were parts of serum. So a fraction of serum was responsible. So they named it as gamma globulin. After this, from gamma globulin, from here they named it as immunoglobulin, and now it is referred as antibodies, okay. Antibodies. So they thought this fraction of serum, a part of serum, a fraction of serum were responsible for all these activities. Then at that time, this was known as this, what you say, this body fluids, okay. These all were body fluids now. So it was known as body humor, okay. Body humor at that time. So the immunologic event that all were occurring with help of all these things, it was known as humoral immunity, okay. So now we know about humoral immunity. Okay, let me get a new board again. So after this, you remember that von Behring we discussed earlier, von Behring and this Kitasato, their observations were applied to clinical, like clinics and all. So what they did, they took the anti-serum and they used to administer it to the patients, okay, patients. And from there, this type of this transferring of this immune protection, okay, immune protection, or what you can say, protection between individuals, okay, individuals, this immune protection between individual is called passive immunity, okay. Remember it, it's very important, passive immunity. And on the other hand, with the help of cells, like these cells, they could produce their own what do you say, protection. They could protect themselves, like what do you get, they could produce the antibody by producing antibody and all by the body itself. It makes it so. It was known to be said active immunity, because it's producing its own immune system and all. It's producing its own antibodies, and all these were occurring with the help of cells. So it was cell mediated immunity. So what we learned earlier, we learned about the humoral, and now it's the cell mediated. And this cell mediated is occurring with the help of cell. This cell is producing the antibody and all, and from there we are getting active immunity, like this passive immunity and active immunity. So what happens in passive immunity, it's quick, okay, it's quick, but it's short-lived, and it cannot produce its own antibody. Antibody must be administered to the individual. But in active immunity, what happens, it produces its own antibody, because the cell is transferred to the, what do you say that, to the individual or the host, you can say. So the cells are transferred, so it can now produce its own own immunity, okay. It can produce its own immunity. So this is active immunity, the basic difference, and it is little bit slow but long lived, okay, long lived. So the basic difference is these two, it comes under the adaptive immunity, and one more is there, like the innate, it's the first layer, okay. Like from here, chemical barrier, physical barrier, all those come under the innate. It's present on us from, what is it, from the time we are born. From that moment onwards, we have that innate, and this adaptive throughout our life we adapt. The immunity is known as adaptive immunity, okay. So let me get a new board again. So by now we got idea that it involves both, okay, humoral and cellular components, both, like both are responsible. So how are they linked? So research have been carried out throughout. In 1950s, they discovered lymphocyte, okay. Lymphocyte, what is this lymphocyte now? This is a white blood cell, okay. WBC, white blood cell. It is a white blood cell, and this is earlier it was thought that this is means it is responsible, like it is responsible for both the cellular and humoral. For this both lymphocytes are responsible, and later on they again discovered that there are two more types of lymphocyte. One is T lymphocyte and another is B lymphocyte. T lymphocyte is also known as T cells, and B, obviously it is B cells, okay. So it's hard to remember TB. So from origin, okay, its origin is from thymus, and its origin is from bone marrow. So from origin we can remember like where and how this. So basically these T cells are responsible for that, what you say, fights and all, cellular immunity. This T cells, it provides T cells, this provides us cellular immunity, okay. And this B cells, it produces those antibody, okay. So from here the concept intertwined, okay, it intertwined, and the controversy was over, okay. The controversy was over. From here we got our concept about that it involves both humoral and cellular components. By linking this T and B from lymphocyte, we are now able to know that immunity involves both cellular and humoral components. So it's for today's class this much only. In next video we will know about how this T and B cells, how this origins and all. We'll learn about everything. Just keep on watching. Thank you.